don't get me wrong, sometimes Telegraf and Grafana and Prometheus and all of these InfluxDB, sometimes all of these heavyweight monitoring systems have a place. They are robust, they are battle tested, and let's be honest, sometimes it can be really fun to know exactly nitty-gritty details about your remote system. Sometimes though, all you want is a lightweight dashboard to show you, well, this host has been using this much CPU today and has this much disk space left, and my hard drives are running at this temperature. If that sounds like you and you don't fancy setting up an entire stack of stuff, Beszel might be what you've been looking for. It's a lightweight, simple way of monitoring servers. Not just Linux, but you can also run it on Windows too. I'll show you how to do that towards the end of the video. And also I'm going to show you how to connect a remote Proxmox system, in my case, running in England, across the Atlantic Ocean back here to Raleigh, North Carolina, using nothing but Tailscale with no ports open in your firewall. I'm Alex from Tailscale, and today we're going to look at Beszel. It's really easy to get started with Beszel, and thankfully it's completely self-hosted, it's completely free, and it supports a whole bunch of monitoring and alerting stuff too. So you can plug it into Telegram, Slack, Discord, email, notify, like it's a whole bunch of stuff. Go take a look at the docs for yourself if that sounds of interest to you. I'll also cover the notification stuff at the end of the video briefly. But essentially, the thing that caught my attention about this project is just how lightweight it is. The agent uses about 8 megabytes of RAM when it's in use, and the hub not much more than that. I can also plug it into OIDC. So you remember in a previous video, I talked about TSIDP. That's an OIDC provider. So you can actually authenticate to Beszel using Tailscale. I'm not going to show you how to do that today. What I am going to do though is show you how to configure Beszel Hub to run inside an LXC container on top of Proxmox using Docker. Also going to show you how to configure the binary agent on Linux and Windows 11.2 as a service. That's not as easy as you might think. And then also we're going to configure Proxmox, like I talked about, across the Atlantic so I can monitor servers no matter where they are in the world using Beszel and Tailscale. So Beszel works on the concept of like a hub and spoke type model. And being that I'm using Tailscale as part of this solution, it doesn't actually matter where I run the centralized hub of Beszel. So I'm going to run this on a Proxmox node in my little home lab cluster that I use for all of these demos. It's just running on one of those little Dell 1 litre small form factor PCs. You don't need anything super powerful to run Beszel. It's one of my favorite things about the lightweightness of it. So you can see here, I've just got a standard sort of Proxmox cluster, nothing special going on. I'm just going to create a very basic LXC container here. I'm going to run Docker inside the LXC container and then spin up the Beszel hub inside the LXC inside Docker. Too much inception? I need a spinning top here, don't I? I think I'm in the real world. Anyway, so that's what I'm going to do, and I will cut to after I've created the LXC. So now the LXC container is created. It's completely blank. There's no Docker on it. There's no Tailscale in it or anything. And I've just got this little helper script. I need curl for this, of course, and Debian doesn't ship with curl because it's too bloaty. Let's sigh. Anyway, so what I want to show you is just a little helper script I've got over here at sh.ktz.me, lxc.sh. It's very basic. It's just copying the Tailscale install script and the Docker install script. If you don't trust me to host that script, you can go ahead and do your own thing. I'm just going to pipe that to sh and then let that run in the background. So it's going to install Docker inside the LXC. It's also going to install Tailscale as well. So the end goal here for me at least is to have an environment where I have Tailscale installed and Docker installed. That's because I'm going to use Docker to run the Beszel hub and then obviously Tailscale to connect everything together. So all of the remote nodes that I'm going to be monitoring, so the remote nodes reach out over SSH to the hub. They need to be routable between each other, which is why I'm installing Tailscale everywhere I possibly can. Tailscale is now installed, but of course, because this is an LXC, we're going to need to add a couple of extra permissions underneath. Obviously, if you're not running an LXC, this won't apply to you. But in the Tailscale documentation, you can see here there's a couple of lines here that you need to modify in your LXC configuration. So I'm going to go to this file here, etc pve lxc, and then the container number. So I'm going to get a shell on the Clarkson host. So etc pve lxc 100. And I'm literally just going to add at the bottom these 2 lines and then just write that file out. I'll do a PCT stop 100, which will stop the Beszel Hub container, and then a PCT start 100, which will, funnily enough, start the container. And that's just so it picks up the config changes, which allow it to bind to the devnet ton device underneath. This is a containerized thing. Again, it's not a Beszel specific thing, but if you want to deploy Tailscale inside an LXC, that's how you go about doing it. Okay, so now if we go into our LXC container and do a Tailscale up --SSH, the Tailscale daemon is running and everybody is happy. So I'm going to copy my login URL right here. It's going to ask me to sign in as usual with my Tailscale authentication provider. I'm going to pick my standard demo Google account that I use for all of this stuff. And voila, Beszel Hub is now on my tailnet, as we can see here. Fully qualified domain name of Beszel Hub, in my case, Velociraptor. Now, I'm aware I tell you this in every video, but I can't assume everybody watches every single video. So in the DNS tab of the Tailscale interface, there is this option here, tailnet name. If you want a fancy / funny name for your tailnet, we give everybody's tailnet a ts.net domain for free. You can roll your own name here. So if you want to come up with something other than, I think by default it's like tail, hold on, let me go here. Yeah, so my default name was tail6e5bf. Rolls right off the tongue. So what I wanted to do was use the Tailscale kind of name generator to come up with something I could actually say on camera or memorize. Whatever you prefer. There's a whole long list of these names. Go ahead and roll yourself a DNS name. They're all free. Everybody gets one for free. The other thing you're going to want to do is enable HTTPS certificates and magic DNS in order for all of the different layers of what we're about to do to work with TLS certificates and all the rest of it. So with that taken care of, we now have Beszel Hub LXC container on our tailnet. We're going to want to go ahead now and create the Beszel Hub container itself. Now, according to the Beszel documentation, there are 2 ways to do this. One is to run the hub as a binary directly on the host. I'm deciding to eschew that option. I just prefer managing services in Docker. Your mileage may vary, but I just like the ease with which I can manage services using Docker. It's just what I prefer. So that's what I'm going to go ahead and do because this is my video. So they have a couple of options here. So the first one is basically a 2-in-1 file. We are just going to deploy just the hub inside this LXC container. We're not going to do quite yet. Anyway, we'll get to it in a moment. We're not going to deploy the agent just yet. So what we're going to want to do is modify this Beszel service definition so that we can put it onto our tailnet. And lucky for you, dear viewer, I have a file just here, which is going to allow us to drop the Beszel Hub directly onto our tailnet inside Docker. This is leveraging stuff that we've done previously on the channel, Docker deep dives, all that kind of stuff. There'll be links to the previous Docker videos I've done going into all of the nitty gritty details. But for today, if you just copy and paste this Docker file, this Docker Compose file, you should be good to go. So we're spinning up 2 containers. Essentially, this container is going to handle the attaching of Beszel to our tailnet. And of course, we have the Beszel Hub application itself. So I'm going to copy and paste that entire file inside my LXC container, which is running at Beszel Hub. I'm going to SSH as root using Tailscale SSH. No SSH keys required. Mwah, chef's kiss. Okay, so I'm going to create myself a compose.yaml file, and I'm just going to simply copy and paste everything from VS Code straight into here. There's a couple of other things we're going to have to set up on the tailnet side. So we need to create a tag. I don't know if you noticed, but in the Docker Compose file, there is a tag here called Beszel. And we can actually use something inside Tailscale's ACL and grants features to limit which nodes can see which other nodes. So there could be a situation where you have a remote monitoring node and you think to yourself, well, I don't really want that seeing everything else on my tailnet. And so by using these tags, we can limit the scope of the view of the world that these things have, and then it just makes things a lot more secure. So let's go ahead and create that tag in our ACLs first of all. It's straightforward enough to do. So all we want to do is literally just create this line here of tag Beszel You can call the tag whatever you would like. Then the other thing that we're going to want to do is go ahead and generate ourselves a OAuth client. So generating an OAuth client has changed a little bit in recent weeks. We want to generate ourselves an auth key, or more accurately, we want to create an OAuth token that's going to allow us to generate an auth key, or container boot to generate an auth key when the container starts. So all we need to select is auth keys, and this is under our OAuth client. And then of course, add the tag that we want to put in here. So in my case, it's Beszel. And then I'm going to just click generate client. I'm going to copy this secret into my compose.yaml file. And then the other thing that we have to do before we press go is just verify that we have this Beszel Hub JSON file in place. So where are we looking for that? At the moment, we are mounting a volume here, and this file will enable Tailscale serve. Tailscale serve is a really easy way of, think of it like a reverse proxy for your service on your tailnet. Like, you don't have to worry about spinning up a separate reverse proxy anywhere else, and you'll get a TLS certificate for your hub service. There's a couple of moving pieces, I'm aware, but it is worth it. So in the Git repo, the accompanying Git repo, which by the way will include a snippet for the Docker Compose file I've just pasted for you, I'll also include this little snippet, and this is really fun. This is the JSON output of Tailscale serve. So what we can do is feed that into the container and have the Beszel Hub show up on our tailnet without doing any other configuration. It's all done completely programmatically. So where do we need to put this file? Well, for today at least, my volumes are all referencing the print working directory file, which is /root. So I'm going to do make dir -p /root. What else do we have? Beszel Hub, and then tailscale /config. And then in that directory that we just created, Beszel Hub, tailscale config, I am going to put bezelhub.json. bezelhub.json. Boom. And so this is essentially going to proxy the port 8090 from inside the container out to port 443 on our tailnet. And in the process, because TSNet is owned by Tailscale, we do a little bit of magic behind the scenes to enable TLS certificates for free. So wish me luck. If I now type a Docker Compose up, hopefully this is going to pull the Beszel Hub image. It's also going to pull the Tailscale image too. And then it's going to add the two to our tailnet. And hopefully everything will just work. So if we go back now to our Tailscale admin console and view Beszel Hub, we can see that that's on our tailnet as before. This, of course, is the LXC container. And then the container itself, Beszel, is right here. So now if I want to copy this fully qualified domain name, if I just copy and paste that into my browser, you can see that I've got a full TLS certificate. I've got the little padlock. Connection is secure. If we look at the certificate here, it's a Let's Encrypt certificate that was generated this morning. So I'm just going to go ahead and create myself here a tailandscales@gmail.com. This is where we can actually start getting into the configuration of Beszel itself now. Hooray. And we have a working hub. That's it. That's all it took. So let's just recap the steps, because I'm always aware that when I'm explaining things, it takes a long time to explain what is ostensibly just a 2 or 3 step process. So we created an LXC, we updated the packages, we installed Tailscale and then Docker as well inside the LXC. Arguably, you could get away without installing Tailscale inside the LXC, but I like to do that just because of Tailscale SSH, so I can get in there and do stuff. Once we had the bare necessities in place, thinking of a song now. Once we had the bare necessities in place of Tailscale and Docker inside the LXC, we modified a compose.yaml file such that we created the the OAuth client on the Tailscale side. We made sure our DNS was set up. There's actually quite a few steps, aren't there? And then we also made sure that our Tailscale serve configuration was in the right directory as well. And then we created it. It was as simple as that. Very, very straightforward 97-step process. But the upshot is we now have the Beszel Hub running. And now we can start to connect different agents from across wherever your infrastructure is running. So we're going to start just by monitoring these 3 Proxmox hosts in the same LAN. and then we'll do a couple of other more exciting things later on. Now the real fun can start. This is where we're going to start installing the agent on multiple different operating systems. I'm going to focus primarily on Linux here, and we've already shown you how to spin things up using Docker Compose for the hub. So why don't we jump to installing the agent on top of a Proxmox host and connect the Beszel Hub to an agent to start with. So in the Beszel documentation, there is an agent installation page. You can see that they support running the agent as both a Docker container and also a binary. Now I've kind of shown you the gist of running a container, a Beszel container through the hub already. So I'm going to deploy my first agent as a binary on top of Proxmox, on top of Clarkson, my primary host in this Proxmox cluster. They've got a one-line install script. There are a bunch of manual steps here if you would prefer, but I'm lazy and I don't actually mind these one-liners too much, especially when I'm doing these demos. So I'm going to run this install agent script now, and now it's going to ask me for my SSH key. So I need to jump back to Beszel, back to my hub that we deployed earlier, and click on this button up here of add a system. So I'm going to call it Clarkson. And for the host or IP, I could use a Tailscale IP, or I could use, in this case, the local LAN IP because it's routable on my sort of local LAN subnet. But just for the sake of argument, I am going to use the Tailscale IP just to prove to you that that works. And I suppose in doing so, it also shows that this host could literally be anywhere in the world. I also need to make sure I select binary here too. I just nearly missed that. Now, there is a one-line option here of copy Linux command. I'm actually going to do that and see what difference that makes to the install command right here. Oh, I see. So it just embeds the SSH key directly as an argument that it passes to the script. Nice. Okay, so now I've done that, it should just be hands-off keyboard time, apart from answering questions. Daily updates for the agent. Yes, please. That sounds good. And now if we go back to Beszel, it's already working. Goodness, I love this software. So many times with these things, there's like these little gotchas and all that kind of stuff. But we can see here it's pulling in the IP address, the Tailscale IP address. Uptime is 0 hours because I only rebooted it just before I started recording. Kernel is a Proxmox PVE kernel of 6.8, and here is the CPU. I told you it wasn't a powerful system, a 6600T i5 CPU. And you can see here that it's just monitoring now quite a few little things. It's picked up things like the NVMe sensors, the core temperatures of CPUs, all that kind of stuff. Network bandwidth, you can see is still pretty low. So we probably need to let this run for a little while in order to have some actually useful stats. But in order to just give you some kind of an idea of the scaling you can get with Beszel when you have it across multiple different agents and different hosts and that kind of thing, here's what my personal deployment of Beszel looks like. So I'm going to go to the grid view here, and you can see I've got, what's that, 6, 7 hosts, 2 of which happen to be the same. I'm going to get onto Windows in just a minute because there's a whole couple of extra steps to run a service on Windows that is a barrel of laughs. But it's essentially, you can see I've got the Home Assistant plugin turned on here. So you can monitor things like Home Assistant. There is an add-on for Beszel in here. So if I literally just search for Beszel, I think I had to put a custom repository in. I won't get too much into the Home Assistant side of things in this video, but you can see there's a custom repo here for the Beszel agent on Home Assistant. I can monitor Linux hosts. Deep Thought is another Proxmox host I have. Morphnix is a NixOS host that I'm monitoring. This is actually my primary media server. So if I go back, I don't know, 24 hours, you can see last night, this is around about when we were watching some TV, you know, not a big spike, or doing some downloads or something. Not a big spike of stuff going on really, but I like that I can see what each of my different containers are up to in terms of like their RAM usage over time. Is just some nice stuff in there. Disk I/O throughput, again, 120. I guess there was some kind of like a ZFS scrub going on or something like that. It's just really nice to be able to spot these patterns, and you can see like all of my hard drives, for example, temperature-wise, pretty stable. You can do things as well like add and monitor extra file systems by passing extra environment variables to the agent. either through a Docker container's environment variables or just setting them on the host itself. So we're going to dig into documentation slightly over here and just take a look at the environment variables section. And you can see here are all the different things that you can configure, all the different syspath for sensors and that kind of thing in case some certain things aren't being picked up, or indeed a whitelist of temperature sensors to monitor if too much stuff is being picked up. Where it really started to pique my interest was GPU monitoring. Now I've got a couple of Ollama instances running in this house, just testing stuff again for this channel and doing some stuff with Home Assistant and their LLM integrations. And you can see that Beszel uses NVIDIA SMI to monitor NVIDIA GPUs. Now my personal installation of Beszel has a node in it called Nix NV Llama, and this is a Nix OS host with an NVIDIA GPU passed through to it on top of an AMD EPYC 7402 system that I have in my basement. And I wanted a way of monitoring the GPU power draw. You can see at idle it's sat right now at 15 watts, give or take. And you can see it's drawing 15 watts, doing absolutely nothing at all. So, but we can see, like, if I want to, solve FizzBuzz in TypeScript, for example, it's now going to pull in my Nix NV Llama host is going to be running fully locally using the latest Llama 3.2 model. This is using OpenWebUI, which again is a bit of a departure from Beszel, but I'm just trying to show you, like, if you put load on these things, you can actually see that you can monitor that in pretty much real time inside Beszel. And you can see that my A4000 GPU here has had some stuff come through on it. So I'm a huge fan of this Beszel agent, but where it gets interesting, at least, is how it picks up that NVIDIA SMI path. So in my case, I worked with my good friend Claude to write a NixOS module, a very simple, basic module for deploying the Beszel agent on top of Nix. If you're interested in that, the source code will be linked in the description down below. You have to make sure that your path includes NVIDIA SMI. And the way to do that, for me at least in Nix, was to include the current system bin path as part of my path, as part of the service configuration, as you can see here for the systemd unit. This also applies to the Windows installation a little bit later on, because in WSL2, NVIDIA SMI isn't quite where Beszel expected it to be. I'm connected in here to a Windows 11 desktop. This just so happens to be my gaming desktop next door. And the reason I wanted to monitor it was because it's got an NVIDIA 3080 in it. What I wanted to do was spin up Beszel agent in WSL2, because that was the recommended way that the developer for Beszel suggested we go about running Beszel agent on Windows. The downside of doing it in WSL2, though, is that it's running inside a virtual machine, and as such, the agent only has a view of the world that matches the view of the world that the virtual machine has. So it's got the same limitations of CPU and of memory and all the rest of it. So whilst it does work under WSL2, and I've written a blog post explaining how to do it, I'm actually not going to show you how to do the WSL2 part today, because I figured out how to compile the native Go binary for Windows, and then you get all of the metrics from your Windows host directly through into the agent as well. Now, what I must say at the beginning of this is instructions for both the WSL2 and the native Windows Service compiled version are available on my personal blog, but you must proceed at your own risk, because there is a GitHub issue on the project for Beszel stating that Windows Defender finds an issue with the agent.exe file once it's compiled. I didn't personally run into this issue, but you might. And I just want to, in the interests of full transparency and disclosure, just say, proceed at your own risk. Okay, here be dragons. Now, compiling this is actually pretty straightforward if you've got access to a Linux box. And of course, you're from Windows these days, you do through WSL2 have access to a Linux box. So what we can do is, well, first of all, we've got to make sure that we've got Golang installed on our Ubuntu desktop. So sudo apt install golang go, I think is what it is. Yes, already installed, because I've already done it before I made the video, but such is life. Next up, we want to clone the Git repo. Now, the end result that I'm aiming for here is to be running the agent.exe file as a native binary on the Windows host, but running it as a Windows service. And that was the tricky part for me that took a little bit of figuring out using something called NSSM, Non-Sucking Service Manager. We'll get to that. Don't worry. We will get there. But in the meantime, you need to compile the agent for Windows. So clone the Git repo, go into the Beszel directory, and then you want to look for this command next. We want to go into Beszel command agent. So we're already inside Beszel. So change directory into Beszel command agent. And then we need to compile it. So we're going to just put these command line flags in place here. Go OS equals Windows. The architecture is AMD 64. A couple of other build flags, blah, blah, blah. Boring, boring, boring. And this is going to compile now. If I look in this directory here, we've just compiled the Go code into an exe file, which obviously now we can execute on Windows. But how do we get it out of WSL2 onto our Windows hosts? Well, Microsoft thankfully made that pretty easy. So if we look under Mount C, you can see that we've just got our standard Windows file system just here. So if I look under Users, Alex Desktop, I can list all the files that are on my desktop, which means I can literally just copy agent.exe out of there, not CD. I want copy. Copy agent.exe onto my desktop, and now on my Windows machine, I should have agent.exe. Now the next step we're going to want to do is create a directory under program files. I just call mine Beszel agent. You can call it whatever you want. And you can see I've actually got some previous stuff from where I was messing about. You don't need half of this stuff. You literally just need the agent. Okay, once you've copied the agent file over into your program files directory, I'm not going to do that because mine's working just fine in the background. We need to go ahead and configure the NSSM side of things. So this is a super old project. And I honestly hadn't been to this website in maybe a decade or more, and I'm not sure it's seen any, the website at least, has seen any updates since then, but doesn't matter, it still works. So NSSM, I use Chocolatey to manage packages on my Windows hosts because I'm a Linux guy and I like the command line. So we go to PowerShell and then run as administrator, and we can just do choco install NSSM, and that's going to pull down the NSSM binary for us and put it onto our path. So now we can do things like create services, start them, stop them, all the rest of it. And you can see in here that we have a very simple set of instructions to follow. We're going to install a service named Beszel Agent, pointing to the exe file that we just compiled and put into our program files directory. Obviously, make sure these paths match up with what you created a few moments ago. And then in terms of what we want to do for configuring the host itself within Beszel, we need to grab the SSH key, the public SSH key from Beszel. So we would go to add system like this and then binary, and we'd call this Windows. And I think in my case, it's 7.54. I would copy the SSH key just here, not the Linux command this time. I'm going to add this system. You can see it's just called Windows for right now. But if I go back into my Windows app here, what I'd want to do is run this NSSM set Beszel agent command, and we're just basically setting an environment variable, same as we would do with like a systemd service or something like that, of key equals and then the SSH key. And then we quite simply just start the Beszel agent services, and that's that. It should just pick it up right away. And I'm not going to break my existing deployment just for the sake of this demo, because I don't have loads of Windows systems in this house to demonstrate this on. But you can see that Windows 11 is up. I just turned it on a few minutes ago before recording this segment, which is why the graph was empty. And you can see it picks up everything I've got in there. So I've got Windows 11 desktop, uptime is 44 hours, even though most of that was just spent in suspend and sleep mode. Here's a specific kernel build of Windows that I'm running, and it's got a 9800 X3D in it. And then if we scroll down, we can see that the GPU power draw is picked up. So it's using the native NVIDIA tooling to pick up some of the GPU metrics and that kind of thing. I'm actually kind of amazed that this is working, Hogwarts Legacy, over Windows Remote Desktop of all things. I'm not even doing anything fancy like Moonlight or anything like that. So the general point, though, is just to show you that, you know, I've put some load on the GPU, and you can see that CPU's gone up, memory's gone up a little bit, disk IO, all that kind of stuff. But GPU power draw now is starting to get where we would expect it to be running a AAA title these days. So for me, I think Beszel is really useful across multiple operating systems, and there are ways to run Beszel with LaunchD on macOS as well, which I won't get into today because it's a pain, to be honest, but it does work. So, you know, the gist of Beszel here is that you could create a very lightweight way of monitoring your entire tailnet using nothing but a very simple, you know, couple of commands to add things via the tailnet using the public SSH key authentication model that it uses to talk between the agent and the hub. And so in situations where something like maybe Prometheus and Grafana is a bit too heavyweight for you, or something like netdata might be a bit too big and a bit too heavy, Beszel is the perfect situation. Like it's a beautiful middle ground between Uptime Kuma, which is just monitoring things like a ping pong web request and that kind of stuff, although Uptime Kuma is awesome in its own right. This is much more useful for monitoring things like system stats, like you can see, like GPU power draw, temperature, disk temperatures, whether your file system fills up and all that kind of stuff. And I haven't even touched upon any of the notification features that Beszel offers either. It supports this Shouter library, which supports, as you can see, notifications for Discord, email, if this then that, Mattermost, Notify. That's great because that's another self-hosted, so you can keep it completely. It's a self-hosted notifications stack, so you can keep everything in-house if you need to. Slack as well, Telegram. My goodness. This tool is legit, and I think Beszel is going to become a real part of my arsenal moving forward. So as you can see, it's a really quick and easy way to monitor multiple hosts across not just your LAN, but also your tailnet too. And again, just look how easy this is to add a new host. This host is in England. I'm in North Carolina, and we're going to add a host on the other side of the Atlantic to Beszel in a couple of minutes. So I'm going to go in here. I'm going to name this Snowball, which is the name of the host. I'm going to go into my tailnet and grab the IP of Snowball. So Snowball is over here, and I'm going to do this. I'm going to copy 100 dot whatever, put that in here, copy the Linux command, and then I'm going to go to my terminal window and just copy and paste the install agent script in here. And I'm going to add a host on the other side of the world to Beszel using Tailscale in, how long was that? Like 30 seconds. And so there we are. I have just added a host on the other side of the Atlantic to my Beszel hub using Tailscale as a connecting fabric. As long as those two hosts can actually see each other, you know, they're both on the same tailnet and are routable, so you can check that with Tailscale ping on the command line. Make sure you've not got any ACLs or grants in the way to prevent them from seeing each other. It's very easily done once you start messing around with those things. Those two hosts can now see each other, and my Beszel hub can now monitor that remote Linux host in England with no firewall rules open or any other configuration. Reasons like this, projects like this are just why this job for me is so easy, is because I find this stuff really fun, just connecting stuff together that perhaps shouldn't be talking to each other. Using Beszel, I can now monitor this host remotely, and I didn't have to really do a whole bunch to make that happen. It's so cliche. It sounds so cheeseball, but I love Tailscale. So a big thank you to those of you that have made it to the end of this rather long video today. And until next time, thank you so much for watching. I hope you have a wonderful 2025. I've been Alex from Tailscale.